Welcome to Spaceverse, your portal to cosmic adventures. Have you ever imagined watching a city form, not a city on Earth, but a vast, cosmic metropolis made of galaxies? Thanks to the James Webb Space Telescope, we're not just imagining it anymore. We're witnessing it. What astronomers are observing is nothing short of breathtaking, the buildup of one of the largest structures in the entire universe. It's called the Spiderweb protocluster, and it's located about 10 billion light-years away from Earth. That means when we look at it, we're seeing it as it was just 4 billion years after the Big Bang, a young structure still coming together, still growing, still shaping the future of our universe. It's like magic, right? This is the universe's version of urban development, with hundreds of galaxies clustering together to form what will become a massive galactic city. Let's break down what makes this discovery so exciting. The Spiderweb protocluster isn't new to science. It has been studied before with other telescopes, but not in this kind of detail. What makes this recent research so remarkable is the use of JWST, the James Webb Space Telescope, a $10 billion marvel of engineering with a powerful infrared eye that can see further and clearer than anything before it. With just 3.5 hours of observing time, the team behind this study managed to uncover new galaxies hidden within this protocluster, galaxies we didn't even know were there. And that's the beauty of JWST. While visible light telescopes are often blinded by cosmic gas and dust, JWST uses long-wave infrared light, which can slip past these obstacles. This means it can pierce the thick veils that have hidden parts of the Spiderweb protocluster from us until now. So, what exactly is a protocluster? It's a galaxy cluster in its early stages of formation, like watching the foundation and scaffolding of a skyscraper going up. Except instead of steel beams and cranes, we have gravity, gas, dust, and cosmic time pulling everything into place. The Spiderweb protocluster contains around 100 known galaxies, and it's not just a chaotic jumble of stars. It's a carefully coordinated structure, growing in complexity and size, with new members being added as galaxies are drawn together by gravity. As Jose M. Perez Martinez from the Instituto de Astrofísica de Canarias puts it, we are observing the buildup of one of the largest structures in the universe, a city of galaxies in construction. Now, here's where it gets even more interesting. Most galaxies in nearby clusters, the ones closer to us in space and time, are old, quiet, and not forming many new stars. They're like retired cities, still grand but no longer expanding rapidly. But the galaxies in the Spiderweb protocluster are very different. They're young, active, and bursting with energy. We're catching them in their adolescence, a chaotic but crucial period when their physical properties are still being shaped. This gives astronomers a unique chance to study how these galactic metropolises evolve, how they grow from wild, star-forming regions into the massive clusters we see today. And yet, for all that we thought we knew about this region, JWST revealed secrets that surprised even the experts. One of the key discoveries was that some of the previously known galaxy members, the ones we thought were thick with dust and gas, aren't nearly as obscured as we expected. Rhythm Shimakawa from Waseda University explained, as expected, we found new galaxy cluster members, but we were surprised to find more than expected. We found that previously known galaxy members, similar to the typical star-forming galaxies like our Milky Way galaxy, are not as obscured or dust-filled as previously expected, which also came as a surprise. This could mean we need to rethink how galaxies in such early clusters grow and evolve. Traditionally, we believe that interactions and mergers between galaxies, essentially galactic collisions, are what trigger most of the star formation. When galaxies crash into each other, gas is compressed, triggering massive waves of new stars being born. But in this case, that doesn't seem to be the primary driver. Helmut Dannerbauer, also from the Instituto de Astrofísica de Canarias, offered a fascinating alternative explanation. According to him, what we're seeing might not be the result of galactic collisions at all. Instead, star formation could be fueled by gas accumulating across large-scale structures in the protocluster, vast, filament-like regions that stretch across space. It's like clouds gathering over an entire landscape, not just at the site of a storm. These galaxies might be quietly growing through steady inflows of gas rather than violent mergers, a gentler, but no less important, path to becoming massive star cities. This discovery opens up a whole new layer of understanding about how the universe formed. We're not just talking about galaxies anymore, we're talking about the scaffolding of the cosmos. These massive protoclusters eventually become the galaxy clusters we see today, some of which can contain thousands of galaxies, trillions of stars, and untold numbers of planets. And they're not randomly placed. These structures grow along cosmic filaments, strands of dark matter and gas that weave through the universe like threads in a vast tapestry. The Spiderweb protocluster is a perfect example of this, galaxies and gas drawn together into a dense web pulled in by gravity, shaped by time. And JWST? It's giving us our clearest view yet. With its infrared capabilities, JWST doesn't just peer through dust, it sees the hidden engines of galaxy formation. It detects hydrogen gas, the raw material for stars, and maps out where it's flowing, collecting, and collapsing into new suns. Ground-based telescopes can't do this with nearly the same clarity. Earth's atmosphere blocks much of the infrared light, and light pollution adds more noise. Even the best observatories on mountaintops can't match JWST's position in deep space, far from interference, cooled to near absolute zero, and equipped with technology that pushes the boundaries of what we can observe. And the most amazing part? These incredible findings were made in just 3.5 hours of observation. Imagine what we'll learn with dozens, hundreds, or even thousands of hours focused on other regions of the cosmos. The Spiderweb protocluster isn't just a curiosity, it's a case study in how the universe assembles itself. It's a look into the past that helps us understand the future of galaxy formation, of cosmic structures, and maybe even of our own place in the universe. These discoveries also act like time machines. When we look at the Spiderweb, we're looking at light that's traveled 10 billion years to reach us. We're seeing a version of the universe that no longer exists, but which helped build the one we live in today. It's not just astronomy. It's cosmic archaeology. So the next time you look up at the night sky, remember this. Somewhere out there, or rather, somewhen, a city of galaxies is being born. Not with bulldozers or blueprints, but with hydrogen, gravity, and time. And thanks to the James Webb Space Telescope, we're finally there to witness it. And that's it. Thanks for watching Spaceverse, where we explore the wonders of the cosmos, one galaxy at a time. From ancient protoclusters to newborn stars, the universe is always building, always evolving. If you're fascinated by cosmic cities like the Spiderweb protocluster, don't forget to like, subscribe, and join us as we uncover more hidden structures in the grand design of the universe. Until next time, keep looking up.